Okay, so now what we're going to do is we're going to analyze the information that comes out of our Python program for the process of computing slopes at given points. Okay, again, the Python program was used to create a smaller and smaller delta or difference and ended up coming up with the value of the slope for a given function. And again, we're focusing on power functions here at a given point. So here's our data for y is equal to x squared. Okay, y is equal to x squared. And what we're going to do is we're going to highlight the values. We're going to say insert a scatter plot. And we can see here that this is very much a linear function. We're going to add a trend line. We're going to display the equation and the r squared. So the equation says, that tells us what equation is the fit, the current fit here, and the r squared value, if it's equal to 1, that tells us it's a perfect fit. So for y is equal to x squared, the equation that specifies the slope at any given point is y is equal to 2x. Let's go take a look at y is equal to x cubed. Alright, so we're going to insert a scatter plot. Now we can tell right away this is not a linear function. So what we're going to do is we're going to add a trend line. We're going to display the equation. Obviously that don't have a very good r squared value. We're going to try a polynomial of power 2. So we're saying 3x squared, and look at that. The r squared value is 1, so we have a perfect fit. And this 2e to the minus 13 is just some niggling little leftovers that we don't have to worry about. So the function for when our initial function is y is equal to x cubed, then the resulting function for the slope is 3x squared. Let's go take a look at the next one. Y is equal to x to the 4th. Insert our scatter plot. Again, not linear. Add a trend line. We'll display the equation and r squared. We're going to start with a polynomial. Now a polynomial of order 2 doesn't fit very well. So let's just try this. We'll do an order 3 and look at that. Again, some niggling little leftovers, tiny little numbers. Our r squared value here is 1, so we have a perfect fit. So the slope function for an original equation of y is equal to x to the 4th is 4x to the 3rd. So if I want to know the slope for y is equal to x to the 4th, I use the equation y is equal to 4, or the slope here is going to be 4x to the 3rd. Okay, let's move on again. So what you've done is for each one of these sets of data, you've changed the x func to be y is equal to math.power x comma 2, x comma 3, x comma 4, x comma 5, and then recorded this information and put it here in the spreadsheet. So let's again do a scatter plot. I think you're probably guessing what our trend line is going to start looking like here. Again, linear doesn't work at all. Order 2 polynomial doesn't work very well. Order 3 polynomial is better but not perfect. Look at that. Order 4 polynomial, I've got just a little bit of leftover junk here. Again, these incredibly tiny little numbers. But the important thing here is for y is equal to x to the 5th, the slope function is going to be, the slope is equal to 5x to the 4th. So for y is equal to x to the 5th, the slope is 5x to the 4th. So let's summarize this over here. So if our initial function is x squared, then the slope function is 2x. If the initial function is x to the 3rd, then it's 3x squared. If the slope function is y is equal to x to the 4th, or the initial function is y is equal to x to the 4th, the slope function is 4x to the 3rd. And finally, for the initial function of y is equal to x to the 5th, the slope function is 5x to the 4th. So we summarize this by saying as the change in y, change of x. Okay, so the delta y, delta x, as x approaches a very, very tiny number, That defines the slope at that point. That's called dy dx. This is the differentiation. So the differentiation for the power function, so dy dx for an initial function of x to the nth is nx to the power n minus 1. So this is the power function for differentiation. This is one of those cookbook methods that you will learn for calculus, but we've actually derived this or deduced this by running our Python program and getting the various values and matching up the resulting curve.